Alrighty, keep this a little bit short. I just want to give us a taste of organic compounds while we're talking about molecules and stuff, because these are all going to be molecular compounds. Okay, there's a lot of crazy, ridiculous, awesome chemistry that happens with organic stuff. We're just going to bounce off the surface for a little bit here. Our goal, my goal, is we really only need to be able to identify organic compounds, identify things that are hydrocarbons, and identify and know the formula for methane in the name. Okay. Other than that, we're going to save all of this for our organic chemistry classes. All right. In the early days, I love this little history bit, but so like, uh, I wish I had a year on this so that I knew, but there was this theory called the vital force theory, and the vital force theory put forth that anything that was organic, well, no, hold on, back up. There was the divide between organic and inorganic was a little bit more straightforward than it is now. Um, Organic things came from living organisms, and inorganic things came from the earth. Okay, so it was nice and cut, clear divide there. Um, and the vital force theory told us that uh, only living organisms could make organic compounds, right? There is something innate about the living organism that gave them this power to make organic compounds, okay, that humans weren't going to be able to do it. And it was this guy, Frederick Bowler, who kind of put this idea to rest. And he did this reaction where he took silver cyanate and silver, yeah, whatever. Losing my mind here. He took silver cyanate and ammonium chloride and reacted them together. He saw precipitated silver chloride, but he also made urea, which looks like this. Okay. And urea is an organic compound. So this is one of the first instances of a human making organic compound, which kind of poo-pooed the idea of vital force theory. And so now we've blossomed into this whole area of organic chemistry, and really organic chemistry just means that we have a lot of carbon going on. Okay. So the diversity of chemistry, of organic chemistry, happens because carbon, people say carbon's a whore. Okay. It forms 4 bonds. It'll form bonds with carbon. It'll form bonds with other things, most other things. And it'll form multiple bonds. It'll form rings. It'll do all this crazy stuff. But yeah, so really our goal here is, can we recognize things that are organic compounds? So our goal is they must have a carbon. They probably have hydrogen, lots of hydrogen. They may also include oxygen, nitrogen, sulfur, some halogens. And they might include other stuff. I'm going to try not to throw too many crazy things at us. But this is just an array of compounds that we can look at to say these are organic things, right? Carbons and hydrogens and oxygens, right? All this kind of stuff. One I want to point out for us here is that we need to know methane. Methane is CH4. This is natural gas, the thing that lights our Bunsen burners in the lab and all that fun stuff. So we want to know the formula name for methane. Our book will give us the names of all the straight chain hydrocarbons up to decane. We're not going to stress about it, but this is what they look like. I'll save all the organic nomenclature for the organic class. Yeah, so we have to be able to recognize organic compounds. The other thing is, I want us to be able to pick out when we have a hydrocarbon and when we have just another organic compound that's not a hydrocarbon. Okay, hydrocarbons are only carbon and hydrogen, right? So this is just a short sample of a handful of those, right? These guys here are also hydrocarbons because they're all just carbon and hydrogen. Okay, so we gotta be able to pick those out. All right, let's take a stab at this. Our goal here is, can we pick out which ones of these are organic? And it shouldn't be too terrible. I'm sorry, this one here's a bunch of carbons, bunch of hydrogen, some oxygen, hydrocarbon, not hydrocarbon, organic. This guy, no carbon, ionic compound, not gonna worry about it. Here we go, hydrocarbon, C4H8, There we go. Let's see, this guy here, calcium carbonate. This is ionic. It has a carbon, but it's not organic. Okay, here we have carbon, hydrogen, hydrogen, nitrogen. That dude's organic. Same thing down here. This is acetic acid, so carbon, hydrogen, oxygen, another hydrogen. That's organic. We could argue either way about this guy. I'm going to say this is not. This is ionic. I shouldn't write not ionic, but you know what I mean. No, this is ionic. Right. This is acetate, which is derived from acetic acid, so it could fall into the organic category. But just for consistency's sake, this I'm going to say this is not organic for us, just to lay it out there, make it a little bit straightforward. Okay. Um, if you need anything, let me know. Um, I'll catch you later.